Good evening, students. All right, welcome to one more session of your WOC. That's nothing but your Vani ma'am back again with one more session of your term one revision. Yes, we are almost nearer to the exam. Yes, students, we are almost there. If I have to tell you, double digit number, right? 14th December is your exam, and let's start off with the term one final that's on the day two. So, day one revision, that's your the chapter haloalkanes, haloarenes, I've already uploaded. Yes. In that particular day one, I have completed that's nothing but introduction for your haloalkanes, haloarenes. I have done the concept called nomenclature, I have done the concept called classification, and I've also done the concept of preparations. I have done the concept of chemical properties in that. All right. Yes, right. Along with this, two important things I have done yesterday. That is, one was the concept which I have explained, and I have done the MCQs also related to that. Got it, students? Now, today the time has come. We are on the day two. All right. Yes. Let's start off with the session. Let's see what topics we are going to learn, the concepts, and also we are going to learn the MCQs related to that. All the best, students. WOC is always with you all. So my request, watch term one or the day one particular video and then come back to this day two. All right. Today the topic of discussion is nothing but the Markovnikov's rule and the anti-Markovnikov's rule. First, we will learn the concept, what is it, and after that, we are going to do the MCQ which are related to your term one examination. Okay, nothing to worry. Let us understand it. Fine. So basically, Markovnikov and anti-Markovnikov rule. Rule number one, or point number one to remember. We are going to take or consider unsymmetrical alkenes. Yes, done. Rule number two is Markovnikov rule is going to happen in the absence of any peroxide, right? There is no peroxide required, absence of peroxide. Yes, this is what is required. Okay, now in anti-Markovnikov rule, you require a peroxide. So compulsory, there should be a peroxide which forms the intermediate. Third important thing in Markovnikov rule is you are going to add HBr, right? That is hydrohalogenation will happen. Remember, important thing. Here you have a positive sign, here you have a negative sign. Remember, the negative addendum goes and adds to the carbon having less number of hydrogens. Remember, the negative goes to the carbon having this carbon having less number of hydrogens. This is what is the rule. Anti-Markovnikov rule is different. The negative addendum goes to the carbon having more number of hydrogens. Br goes to carbon having more number of hydrogens. That's all. Easy. Easy, isn't it, students? That's a more number of hydrogens. Just see here. In Markovnikov, the major product is always 2. Means you'll be getting 2 bromopropane because you took propene, get 2 bromopropane major, and minor would be 1 bromopropane because this carbon is the carbon having less number of hydrogens and it forms a secondary carbocation rather. Got it, students? All right. In anti-Markovnikov addition, 1 bromopropane is a major product and the bromine, a negative part, goes and adds to the carbon having more number of hydrogens. So in case of Markovnikov rule, remember mark addition, what product you are going to get, students? You are going to get major product as 2 bromo or 2 halo rather, whichever alkyl group. In case of anti-Markovnikov, anti-mark addition, you will be getting 1 bromo or 1 halo product. This is what as a major thing. These two are major products. That's all. Easy. Let's start with the questions now. Right, let us see. The addition of HCl to pent-1-ene will give what? Okay, pent-1-ene first of all is an unsymmetrical alkene. Write the structure like this. I'm going to write the pent-1-ene structure like this. Okay, done. This is over. Now what are you adding? You're adding HCl to this. Perfect. This is positive, this is negative. The negative addendum goes to the carbon having less number of hydrogens. So what product you will get, students? You will be getting a compound which is nothing but, I said just now, you will be getting a compound which is 2. Means the basic thing, Here hydrogen goes here and halogen comes here. So this is nothing but 2-chloropentane. Okay, mark always two products are this. One more product is nothing but the other way around. CH3, CH2, your CH2 and your CH2 rather and your CH basically. So here 2, 3, 4, one hydrogen added. So here you have CH2 and you have Cl. So this compound is called 1-chloropentane. So which is major, students? Always 2-chloro is major product. Major, correct? So which compound? So see if it is there's no peroxide in this. Correct, no, students? There is no peroxide. Because there is no peroxide, you'll immediately think it as mark addition. Is it okay? Perfect. Next question. Let's see the next question. The product obtained by the addition of HBr to hex-1-ene. Okay, see here, in the presence of peroxide. They said this, that's why it is nothing but anti-Mark addition. Okay, this is your anti-Mark addition. Let's take the compound hex-1-ene. One is this, second carbon, third carbon, fourth carbon, fifth carbon, and ene. This is hex-1-ene. You're adding which one? HBr. In the presence of what? You're taking peroxide to this. Okay, so benzoyl peroxide. So it is anti-Mark addition. So let me write the product here because maybe I may cover the particular content. So CH3 negative addendum goes to the carbon having more number of hydrogens. So this is what I get. So I'll be getting, always remember students, it is easy. Once you learn the concept, easy. So the product is nothing but 1-bromohexane, right? So always in anti-Markovnikov addition, one product is important. Let us see the next question. Reaction of but-1-ene with HBr gives 1-bromobutane as a major product. Oh, right. Addition of hydrogen halides to alkenes proceeds Markovnikov addition. Perfect. Let us see the students. Reaction of but-1-ene with HBr gives 1-bromoprobutane as a major product. Oh, this is wrong because this is nothing but marked addition. All right. In marked addition, what is a major product? Always 2-bromo. 2-halo products are major. Correct. So they have given here wrong. Assertion is wrong. Next, let us see addition of hydrogen halides to alkenes proceeds according to Markovnikov addition. Okay, yes, because there is no peroxide. Perfect answer. This is right. So check which option. Right. Assertion is false. Reason is true. Let us see the next question. Addition of HCl to propene in the presence of benzoyl peroxide. Okay, this is anti-Markovnikov addition. Okay, gives 2-chloropropane as a major product. Yes, it is right because this is anti-Mark addition. Okay, right. Addition of HCl follows anti-Markovnikov rule due to peroxide effect. Okay, addition of HCl follows anti-Markovnikov rule due to peroxide effect. So remember, students, always one thing. I'll tell you, this is wrong. One important thing. Whenever somebody says peroxide effect, okay, right? Remember, this is observed only in case of HBr. Remember, whenever you have HI and whenever you have HCl, yes, they always fall. This is peroxide effect or anti-Markovnikov effect, anti-Mark effect. And if you have HCl and HI, it is always called Markovnikov addition. Mark addition. Remember this. Okay. Yes. So what do we have here? HCl. They said Markovnikov rule due to peroxide effect. See here. Markovnikov peroxide. Wrong concept, my students. So assertion is right. Reason is false. Sure. Next question. Right. Preparations. Now let us see the preparations of haloarene, students. Yes. So here what happened? Haloarenes can be prepared from benzene. All right. Haloarenes can be prepared from aniline by a reaction called diazotization reaction. Diazotization reaction where aniline is getting converted to your BDC, right? And BDC finally by using the metal halides, either Sand-Meyer's reaction like that, it is converted into your respective haloarene. It can be chlorobenzene, bromobenzene, or iodobenzene, right? So this is the preparations. Further, haloarenes can undergo nucleophilic substitution. Why? In this case, it is going to show resonance, right? When it shows resonance, ortho para positions are open for, or it is rich in nucleus electrons. So automatically it can undergo nucleophilic substitution reactions at the ortho and the para positions. All right, now where para is a stable one, right? This is a stable compound because of its lattice structure, because of its symmetrical structure. So the first one, sodium hydroxide, where the nucleophile is OH, you'll be getting phenol. Here in the second case, sodium cyanide, where nucleophile is CN. In the third case, ammonia, where NH2 is a nucleophile. So you will be having, or you'll be preparing the different compounds by nucleophilic substitution reactions, taking OH as a nucleophile here, Cn minus is a nucleophile, NH2 as a nucleophile. Got it, students? Yes. So this is where your nucleophilic substitution reaction lies. Now let us see further the reactions or the chemical reactions of haloarenes. Okay, see here. Haloarenes can undergo different types of electrophilic substitution reactions also. Why? I said just now. Ortho and para positions are rich in nucleic centers. Yes. So what happens? It undergoes different electrophilic substitution reactions like halogenation. Okay, it can undergo, rather it can go nitrating mixture with the nitration. Yes, it can go with concentrated sulfuric acid, nothing but sulfonation. Yes, students, it can undergo Friedel-Crafts acylation reaction, rather Friedel-Crafts alkylation reaction. It can undergo Friedel-Crafts acylation reaction. Yes, it can undergo Woods reaction. Yes. Okay, now see here you have Rx and both two things are there. Rx is here and aryl halide is there. That's why it is called Woods-Fittig reaction. Woods-Fittig reaction. Then you can use again the same thing using an example. Woods-Fittig reaction preparing alkyl halide to tall. Here in all the cases, in the first case, Cl plus is an electrophile attacking at ortho and para. Para is major. In the second case, NO2 plus is an electrophile. In this case, SO3H is an electrophile. In this case, CH3 plus is an electrophile. In this case, CH3CO plus is an electrophile. Got it? In this case, R plus is an electrophile. Okay, R plus. In this case, CH3 plus. So they are going to go and attack at the ortho and the para position. Now let us see. And as I said, para is a statement. Now let me see whether it is getting recorded or not, students, because again it will be a problem. Okay, let us see. Is it getting recorded? Okay, it is getting recorded. All right, let us proceed further. First question is, aryl halide is less reactive than alkyl halide towards nucleophilic substitution reaction. Why? Yes, let me first take the students. Whenever I take aryl halides, yes, what is the important thing? It is going, because this benzene is electron withdrawing, correct? What will it do? It is going to pull the electrons towards it. It will pull the electrons towards it. Then what will happen? This will be getting a partial double bond character. Yes, right. This has lost. It will be getting a partial double bond character. Now double and double bond can't be together. So what will happen? It starts undergoing, double and double can't be together. It will start undergoing resonance. Yes, students, right. Now what happened? Here you have your CX bond. Perfect. Now CX bond, whatever is there, now because of the resonance, it has got a partial double bond character. Now you only tell me, partial double bond character, does it require less energy or more bond dissociation energy? Yes, yes. This requires bond dissociation energy is more. It will become the requirement is more because it is a double bond, right? So because of this, bond dissociation energy is more. It is less reactive towards NSR, less reactive towards NSR. Okay, got a nucleophilic substitution. So what is it? Large CX bond energy. Easy. Next question. The CCl bond in chlorobenzene as compared with CCl bond in methyl chloride. Is it weaker, stronger, what? Okay, let us see. CCl bond in chlorobenzene. Just now I said because of the partial double bond character, because of the resonance, what is there. Yes, here what happens? Double bond is there, resonance one after the other, right? This in aryl halide, rather in aryl halide, the CCl bond is double C double bond CCl in aryl halide. Let me take methyl chloride. So this is my methyl. Is there any resonance, students? There is no resonance. No resonance. So when there is no resonance, what will happen? No double bond. Okay, no double bond. All are single bonds. So now you only tell me in alkyl halide. In alkyl halide, yes, just check. Aryl halide, it is double bond. In alkyl halide, it is single bond. Now you only tell me, they said CCl bond in chlorobenzene is compared to, yes. Remember always triple bond stronger, bond length shorter, double bond then single bond. Correct. So double bond, what will happen? This is shortest bond length. Shortest bond length. Correct now students? Yes, this is large bond length. When I say now where is a double bond, our double bond is in between. Correct. So remember double bond is shorter and stronger. Option C. Yes, easy. Next question. Chlorobenzene is what? What is chlorobenzene? What is the importance of chlorobenzene? Okay. It is less reactive than benzyl chloride. Okay. What is the reason, students? Why? Right. Now check. This is your chlorobenzene. Okay. Right. Now this is your chlorobenzene which is attached. This is your chlorobenzene. Second, let me take now. This is nothing but your benzyl chloride. Okay. So what happens, students? What happens? Let me write. This is your benzyl chloride. Okay. This is your chlorobenzene. Chlorobenzene. Okay. Now check carefully. In chlorobenzene, whatever lone pair of electrons are there, whatever lone pair of electrons are there in on chlorine, they get involved in resonance. Yes, this bond shifts here. Okay, so double and double can't be here. So what is going to happen? This bond shifts here. So just check. It is going to attain a partial positive charge. 1, 2, 3, 4. Right. This will become negative. This will become negative. Okay, these are lone pair. Now again, this bond shifts here. Automatically, this bond is going to shift here. Yes. So what do you get in the second state? You will be getting a bond here, negative charge here, a bond here, and partial positive charge. Okay, this is positive. 1, 2, 3, 4. Further what happens? You are bond. This bond shifts here. Yes, students, this bond is going to shift. So further, I am going to get a negative charge here and double bond character is already there on chlorine. Now, tell me here in chlorobenzene, especially, yes, in chlorobenzene, whatever electrons are there, they get involved in resonance with pi electrons. Yes, so in chlorobenzene, you'll be getting a double bond. Correct. So it acquires a double bond character. So when it is a double bond, I said it is less reactive because I have to use more energy to break the bond. Correct. The bond length would be shorter, very close, right, students? Yes, I have to use more energy to break. That's the reason chlorobenzene is less reactive due to what? Due to double bond. Double bond character. So in benzyl alcohol, it is single bond. Single bond. So it easily reacts. Easy, students? Okay. Next question. The reaction of of toluene with chlorine in the presence of iron and in the absence of light yields what? Oh, right. Easy question. The reaction of toluene. Let me write the reaction. I have taken toluene. Okay, done. Then what did I do? I have used chlorine. Okay, done. In the presence of iron and dark. Okay, right. In the presence of absence of light. Now, remember, students, first of all, what is the speciality of methyl group? CH3 group is basically OP directing group. Okay, this is OP directing group. Okay, right. Now, this is an electrophile also, correct? So, where will it go and attack? It will go and attack at the ortho position and para position, right? That electrophile, whatever is there, whatever comes inside. So this methyl group allows the chlorine to go into two sites. One is CH3 is here at the ortho position. One more CH3 is here at the para position. Got it, students? Right. So this is orthochlorotoluene. This is toluene, right, students? So, which is stable now? Para is stable. Now, what did they ask me? The reaction of toluene with chlorine. What does it give? Mixture of B and C. Option B is right. Next question. Diazonium salts with copper chloride. Okay, giving me chlorobenzene. So, conversion of BDC to chlorobenzene. Okay, what is this reaction called, students? Nothing but Sandmeyer's reaction. Easy. Okay, sure. Next question. The iodobenzene is generally obtained from diazonium salts by reacting with what? Okay, iodobenzene. So they want me to prepare iodobenzene. Okay, right. So along with this iodobenzene, what they're asking? It is prepared from by you're taking BDC. Okay, you're taking BDC like this N2Cl, right? What if you react here? What if you react here? That you will get iodobenzene. Simple. I will take potassium iodide. Yes, so iodine goes and replaces the chlorine. I get iodobenzene. Nitrogen gas is out and KCl is here. That's all. So this is your iodobenzene. Okay, this is your BDs. What is the correct statement? So to get iodobenzene you'll use, right, easy. Next question. Arrange the following compound in the increasing order of their densities. All right. So the correct important thing. So whenever you have density question is given to you, remember students, density increases, right, as number of carbon atoms increases. Okay, right, and number of X atoms increases. Yes. So X atoms of mass increases. Now see the students. According to this, the correct option is A. Why? This is only benzene. Here you have chlorine. Here you have two chlorines. You have bromine, chlorine. So what is the order? Fluorine less, chlorine less, bromine less than iodine. According to this is the order of atomic mass. Order of atomic masses. Correct, students? So सबसे ज़्यादा this will have more density. Why? Density is equal to mass by volume. So when density is more, mass is more, density also is more. You see? Next question. So they asked me increasing order. This will be more. Next question. Chlorine plus Na plus CH3Cl. Okay, what is this reaction? Yes. Here you're combining one aryl halide, you're combining with sodium metal, you're combining with alkyl halide. Reaction between aryl halide and alkyl halide is nothing but Woods-Fittig reaction. Simple. Next question. Reaction of bromobenzene with sodium metal in dry ether gives what? Okay, right. Now let us understand. Bromobenzene. Okay, I have taken one bromobenzene. Then I have taken one sodium metal. Okay. Why I took two? Because they have mentioned me it is dry reaction, dry ether. So immediately I remember that it is nothing but Fittig reaction. Yes, it is nothing but Fittig reaction. क्या आएगा? So you will be getting 2 NaBr is out, right? This one is out, and you will be getting biphenyl. Two rings you are going to join. Biphenyl or diphenyl rather. Sorry, diphenyl. Diphenyl is what we are preparing. So mark the correct thing. Diphenyl. Easy. Next question. Chlorobenzene undergoes nitration and treatment with concentrated nitric acid and sulfuric acid. Okay, the product is. So what is this mixture? It is nothing but a nitrating mixture. Nitrating mixture. Okay. Nitrating mixture, what is electrophile? NO2 plus is an electrophile. Chlorobenzene is which group? Basically, chlorobenzene is which directing group? OP directing group. Okay, right. So what are the products? Yes, a mixture of orthochloronitrobenzene and parachloronitrobenzene. That's all. Easy. Next question. Arrange the following compounds in the increasing order of the rate of a reaction towards NSR. Okay, right. Towards NSR, it's some students. Yes. So towards nucleophilic substitution. What to remember? Always check. If an electron releasing group is present at ortho and para position, remember, with respect to with with respect to halogen, what will happen? The aryl halides get deactivated. That means if you have electron releasing groups like methyl groups at the ortho and para position, what will happen? The aryl halide, okay, it will this particular reason will deactivate deactivate aryl halides towards which one? Aryl halides towards NSR. Towards NSR. Remember that. Right now. Let us see where it is there. Okay, so methyl group, this is ERG, electron releasing group. This is also electron releasing group. It is present at the ortho and the para position. So which will be least reactive? This is least reactive. Uske baad, this is, if I have to say, this is little bit less because you have para position. This is also less reactive. Okay, now you don't have any ERG group, no ERG group. ERG. So this is max, more reactive, more reactive. Okay, that's all. See the order? Yes, C is the order. Let me take a different pen. Okay, C is the correct answer. Got it? C is the correct answer. Sure. Easy, students? Easy. Let us see the next question. The presence of nitro group at meta position with respect to halogen atom greatly activates the haloarenes towards NSR. Okay, done. In the case of meta-substituted haloarenes, there is no negative charge at meta position in the resonating structures. Oh, right. What did they give me? Very nice. They said, first of all, the presence of nitro group at meta position greatly activates the haloarenes. Okay, remember, whenever you have electron withdrawing groups like NO2, electron withdrawing groups like CN, electron withdrawing groups like COH, right? Right? Which where when you have them at the particular ortho para meta position, remember they have very little effect on the haloarenes. So the important thing is towards which one? Towards NSR. All right, towards NSR the effect will be very less. But important thing is here they have given a position called meta position. Okay, just now I said the effect will be very less when they are there. Effect at meta position, rather, if I have to tell you, yes, effect on aryl halides is less. So, but here they have given it is more wrong. No? Yes. So the concept here is assertion is false. This is false statement. Now, in case of meta-substituted haloarenes, there is no negative charge at meta position in resonating structures. Yes, if you draw the resonating structures as C, yes, this is right statement. There will be no negative charge in the meta-substituted. Okay. Next question. Identify the correct state order of reactivity of the following towards NSR. Okay, yes, students. Now, I said just now, whenever you have electron withdrawing groups, if you have at the ortho position and the para position with respect to halogen, yes, always remember they are, or if it is at meta position, no problem. But if it is the ortho position and if it is the para position with respect, this will activate aryl halides towards NSR. It will activate aryl halide towards NSR. Remember. So as a number of EWG groups, electron withdrawing group increases. At which position? At ortho position and para position. Remember the reactivity of aryl halide increases. Of ARX aryl halide increases. Check karo. Yes. So how many electron withdrawing groups are there? In this case, 3 are there. Okay. In this case, 1 is there. In this case, Two are there. Okay. So electron withdrawing groups are more, right? So that will be more towards reactivity towards NSR increases. NSR reactivity increases. देखो सबसे ज़्यादा 1 is more. Then comes 3. Then comes 2. Then comes 4. Easy? Next question. Stereochemistry of SN2 mechanism. Okay, all right. Now let us start with the SN2 mechanism in SN1. So basically, I said there are two types of mechanisms which we have to study in haloarenes and haloalkanes rather. SN2 mechanism is one, along with the stereochemistry. Let us see. So whenever I talk about SN2 mechanism, first important thing, these are the steps. You need to remember three different steps. First, important here is in SN2 mechanism, we are going to go with less steric hindrance groups. Steric hindrance groups means less bulky groups. Steric hindrance or less bulky groups. Less bulky groups. Got it, students? Okay. Now see here. Here the nucleophile will attack from backside. You will be getting a transition state. So the attack of the nucleophile on the primary, I said less bulky group, the primary halide. So nucleophile will attack from back. You'll be getting a transition state. And after transition state, the reaction is fastest where there is inversion of configuration. Once again, in SN2 mechanism, primary is more preferred than secondary, more preferred than tertiary. Where will the nucleophile attack? From backside. When it is attack, what is happening? The attack of nucleophile, that's the slowest step of the RDS. Done. After this, there is a transition state which is formed where both the OH and Br are attacking on the carbon. And final, the fastest step, there is inversion of configuration. Here check, H1 is here, here only. Your H2 is here in configuration inverted. H3 is here, configuration is there. Br is here now. What happened? Br has gone out and the nucleophile which has attacked from this side has got inverted in the configuration. So in SN2 mechanism, there is an inversion called Walden inversion. So this is the whole summary of SN2. Now further if I see here, less steric hindrance. Methyl is more preferred. Then comes primary because it is easy for the nucleophile to attack. Then comes secondary. Nucleophile will attack from back. Then comes tertiary. Nucleophile will attack from back. But here problem is bulky groups. Bulky groups. Bulky groups. That's why tertiary is less preferred. Methyl is more preferred. Okay? Energy diagram of SN2. Now see students, energy diagram of SN2. I said in SN2 mechanism, there is a transition state formed. Yes. And always remember there is only one peak. This peak is called activation energy barrier, only one peak. Careful. The reactants are where two particular molecules are participating. That's why the rate of the reaction depends upon the concentration of two reactants, rather CH3Br and OH minus, because two are participating. That's why it is called as SN2 reaction. Okay, right. So careful here in SN2 reaction. Remember, two are participating. Remember, nucleophile will attack from back. Remember, primary is preferred or methyl is preferred more. Let us see SN1 and one more thing. Here SN2 mechanism, it occurs in one step only. It is only single step process. Got it? Okay. Now let us see SN1 mechanism, students. In SN1 mechanism, here, important, tertiary is more preferred than secondary, more preferred than primary. Right. Here in the rate determining step or the rate of the reaction depends upon only one concentration term. That's the reason, concentration term, that's the reason it is called SN1. SN1. Here important thing, this occurs in two steps rather. Okay. The mechanism occurs in two steps. Check carefully. Step number one is always the formation of your tertiary carbocation. Formation of tertiary carbocation. Okay, this is your step number one. That is the RDS step. Yes, that's a rate determining step. So in this, after this, in step two is nothing but attack of nucleophile. So the second step is attack of nucleophile, which is the fastest step where you will be getting the formation of the product, tertiary alcohol. Got it? So when I see the energy level diagram, careful for SN2, there are two peaks. You should remember this. There are two transition states which we are going to observe. You have to check that particular thing because in the MCQs they may ask you. So two transition states are there where initially there is only one reactant which is participating, that is tertiary carbocation. Tertiary carbocation is participating, and in the product you will be getting a substituted nucleophile. Okay, now let us see the uh, basic, the whole concept of your inversion, configuration, and Walden inversion. Rather, if I have to say inversion, retention, and racemization. Inversion, retention, and racemization. Yes. So the concept here related are, just see, if you have an attack from front side, you will be getting retention of configuration. Yeah. If you have an attack from back side, you have inversion of configuration. Correct, students? So inversion of configuration is observed in SN2. Retention of configuration is observed in SN1. Got it? So note the order, and in SN1 mechanism, the order of nucleophiles is this because Ri is a better leaving group. Better leaving group. Okay, students? Easy. Right. Easy. Let us start with the questions. Important thing, I have given the comparison of SN1 and SN2 in one page. So everything is here. Learn everything. Whatever is taught, the summary of this is here. Let us see the questions. Which of the following compound will give racemic mixture or nucleophilic substitution reaction? Okay, careful, careful. Racemic mixture, right? Where both the positive rotation and the negative rotation mix together. Now see, careful. First of all, when I say racemic mixture, yes, what should you remember? You have to check for one condition, right? Check for a carbon which is chiral. Chiral, right? Because chiral carbons are optically active. Optically active. Okay. They are going to rotate the plane polarized light. Rotate plane polarized light. PPL means plane polarized light either towards the right or either towards left. Both of them combined together, they form a mixture called racemic mixture, which is optically inactive. Optically, it is inactive. Got it, students? Okay. Now check which one will show or give me the racemic mixture, basically. Yes, which is chiral carbon. See here. Option A is chiral. Why? This is one group. This is different group. This is H is different group. This is H different. Chiral carbon are all four groups are different. Groups are different. Got it, students? That's all. Easy? Chalo. So in this case, two are similar. So this is not thing. This is similar. This is a chiral. In this case, two are CH2, CH3. Okay, no, this also is not possible. So because this is also a chiral. So the first option is chiral. That's why it is going to show the racemic mixture. Is it easy, students? So chiral will rotate the plane polarized light. Next question. The above question. Okay. What is classified? What is this reaction? Easy. What happened? OH is replaced with this X. That's all. Simple as that. What is happening here? Nucleophilic substitution reaction. Easy. Chalo. Next question. A primary alkyl halide would prefer, always obvious, it is nothing but your SN2. SN2 order is methyl alkyl halide greater than 1 degree, greater than 2 degree, greater than 3. Easy? Chalo. Next question. SN2 mechanism, the rate of the reaction is proportional to the concentration of what? Okay, right. SN2 means two molecules are participating in this. So it will depend upon which? Both substrate and reagent. Right. Methyl bromide reacts with aqueous alkali to form methyl alcohol. Okay. Right. Two things are there. Methyl bromide and sodium hydroxide. Okay. The product formation takes place in two steps. Fine, students. Just see. Methyl bromide 2 1 reacts with sodium hydroxide aqueous. What happens? Two are participating in this. Two molecules are participating. What will I get? I'll be getting a compound CH3OH plus NaBr. That's out, or Br is out. How many molecules are participating? Two. So is it SN2? Yes, assertion is right. But they said the product formation takes place in two. Wrong, no, students. SN2 mechanism occurs in one step only. Occurs in one step only. So, one step only. So, reason is false. Easy. Next question. Which of the following statements is correct, incorrect for bimolecular nucleophilic substitution reaction? Second order, which is incorrect, they said. Careful. So, according to this, yes, C option is incorrect. Why? The rate of the reaction does not depend upon the concentration. Wrong. Yes, right. In SN2, SN2 depends upon two things. One, concentration of the substrate, right? And it is going to depend upon concentration of reagent. Both the things it depends. That's why it is SN2. So the wrong statement is next one. SN2 reaction of a compound containing asymmetric carbon atom always gives. Okay, so careful. See here, when you see SN2, inversion of configuration. Easy. Okay, that's nothing but Walden inversion happens. Walden inversion happens. In SN1, no inversion. In SN2, inversion. The order of reactivities of the following alkyl halides. Okay, in SN2, we've already studied, students. Remember, careful. The correct answer is this. Let us write the reason. In case of Ri, what will happen? Bond dissociation enthalpy is less. Correct. It is most reactive alkyl halide. Reactive alkyl halide. Why? Because iodine is large in size. So iodine is a better leaving group. Iodine is better leaving group. Better leaving group. That's why it easily reacts. The correct order is this. Now one more question. Tertiary alkyl halide is practically inert to substitution of SN2 mechanism for why? Yes, because of steric hindrance. SN2 always happens in less steric hindrance groups, in less bulky groups, bulky alkyl halides. Remember, alkyl halides. Got it, students? Okay, right. Next question. In SN2, the correct order of reactivity of the following compound. Okay, so I said in SN2, the order is methyl first, primary second, secondary is third, then tertiary. So which is methyl? This methyl. This is primary. This is secondary. This is tertiary. Easy. Next question. In alkaline hydrolysis of tertiary butyl bromide, which of the following is correct? Okay, you're doing hydrolysis to tertiary. So easy. Yes. Here both are undergoing. Butyl bromide is there. Alkaline hydrolysis is there. So two reactants are there. That's why it is rate depends upon two concentration terms. Correct? Rate is directly proportional to tertiary. Careful. Yes, students. So important. And it also depends upon the nucleophile. That's why it is SN2 reaction. SN2 reaction. Got it? So the rate of the reaction. Careful, students. Easy. Now important thing. How to assume this? I got confused now. What should I do? Careful. Here they have given tertiary. That means, no, I should not get confused because tertiary always happens in which reaction? Tertiary always happens in which reaction? It should happen in SN1. In SN1 mechanism, the order is tertiary more than secondary more than primary. So what should I take? In this case, rate depends upon concentration of only one term. It depends upon concentration of only one term, right? So in this case, the option is wrong. In this case, what should I take? Tertiary. That's all. That's why this is called SN1. Easy. Next question. In alkaline hydrolysis of tertiary butyl bromide, the order of reaction with respect to nucleophile is, okay, tertiary means immediately remember it is nothing but SN1 mechanism. Okay, now order of the reaction they're asking. Let's see. This is your tertiary. Okay. Now CBr. Then you have sodium hydroxide aqueous. Okay, done. What will happen? OH goes and replaces. I'll be getting CH3COH plus NaBr. Okay, done. Now rate of the reaction depends upon only one alkyl halide. Rather, it is uh, here according to this it depends upon only one alkyl halide, correct? So rate is equal to K into tertiary alkyl halide, that's all. So what is it? It 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 with respect to the nucleophile, the order of the reaction is zero because it is aqueous solution, right? With respect to the nucleophile, this is an aqueous, so the order of the reaction is zero because if it is aqueous with respect to nucleophile, that is OH minus, the order is 0. That's all. Don't take first order, it is 0 because it is aqueous solution. In aqueous solution, we don't consider this one, right? That's the reason. Okay. Careful. In SN1 mechanism for the hydrolysis of alkyl halide to an alcohol involves the formation of, okay, SN1 mechanism. Remember, carbocation. Why? Because tertiary carbocation forms first, then secondary, then primary. So let us take one reaction. Tertiary, yes, it occurs in two steps. First step is formation of tertiary carbocation, and then this is your step. So step 1 is the RDS, which forms tertiary carbocation. That's right. Next, the study the correct energy following energy profile diagram. So I said earlier, students, whenever you have two peaks, remember it is SN. Careful. It is nothing but your mechanism. Two things are means it is SN1 mechanism. SN1 mechanism. So whenever it is there, in this SN1 mechanism, it always undergoes or it always happens. To tell you, it always happens with tertiary alkyl. Now, how do I know whether it is this? Remember, students, whenever you have two activation energy barriers, that means activation energy 1, activation energy 2 means the reactions are highly exothermic. Remember, yes, the exact reactions are highly exothermic reactions because a lot of energy is required to cross the energy barrier and form product. See here, product is below the reactant, that's why it is exothermic reaction. Okay, next question. During SN1 mechanism of alkyl halide, the change observed is simple, retention and inversion both. Correct? Yes, both will happen. Both the sides is there. So because it is two-step mechanism, carbocation is formed. Second step, nucleophile attacks. Both the sides it can attack. Yes. Next, which of the following statement is incorrect about SN1 mechanism? Okay, remember SN1 mechanism, you have a carbocation, that is tertiary carbocation formation. This tertiary carbocation formation, whatever is there, is the RDS. Right. Now, what will happen? The increase of concentration of the nucleophile, right? Whatever concentration of nucleophile, if you are adding, suppose if your nucleophile concentration is increasing, yes, will it affect this carbocation because this is already stable? Yes, already stable. So nucleophile concentration does not affect rate, does not affect rate, correct? Yes. So rate depends upon rate depends on substrate only, depends on substrate only, correct? That's all. So simple as that. Yes. So careful. Easy. So it is favored by high concentration. It is incorrect statement they asked. So nucleophile, it does not depend, but it depends upon substrate. So they have given wrong statement. High concentration of this, no. Next question. Which of the following alkyl halides will undergo SN1 reaction most readily? Okay. So SN1 is preferred by tertiary, secondary, then primary. So tertiary is next one. The increasing order of reactivity of the following halides for SN1 mechanism. Okay. So SN1, simple. Remember students. Yes, SN higher the stability of carbocation, higher the stability of carbocation. Remember, yes, higher would be the reactivity, higher the reactivity of SN1, reactivity of SN1. Got it? Remember that. So, among all these, B, because this particular thing, careful, primary less, because SN1 prefers always tertiary more than secondary more than primary. So SN primary is less, then comes secondary, then comes your third one, which is nothing but that too it has an aryl ring. That's careful. More bulkiness is there in this. That's why it is most stable. Clear? Okay. Which of the following is most reactive towards SN1 mechanism? I said, now students, check for the tertiary carbocation. Easy. Next one. Because here tertiary always prefers. This is how do I draw this? It is like, see here. C6H5, CH3 is here, C6H5 is here, and Br is here. So tertiary. Next question. An incorrect statement with respect to nucleophilic substitution reaction via SN1 and SN2 mechanism. Okay. SN1 and SN2 mechanism. Remember, this is the correct option. Why? Competing reaction of SN2 is rearrangement. No. In SN2, there is no rearrangement. Okay. Competing reaction. There is inversion configuration. Yes. But with respect to nucleophilic via SN1 and SN2 mechanism, this is the wrong statement. Okay. Next one. Which of the following compounds give racemic mixture on nucleophilic substitution? Okay, right. Again, I said. So we have checked this. This is already done. This is done already. Okay, we have done. This is the correct option. Please check the earlier one. Okay, this is done. Next question. In aryl halide, halogen atom is attached to. Aryl halide. There's a partial double bond character. Correct. Yes, it is always, the bond is always sp2. Yes, single bond is sp3, double bond is sp2, triple bond is sp. Right. Enantiomers have same. What are enantiomers? Yes, enantiomers are those, or rather, I have to write the definition. Enantiomers are, first of all, optical isomers. Okay, optical isomers. Yes, they are having, what will they have? They have same molecular and structural formula, and they have, and what do they have? Different configuration. That's all. So molecular structure formulas are, configuration is different. That's all. Easy. Right. Next question. So DNL forms a what? Oh, important students. DNL forms a specific rotation. Remember, first of all, whenever somebody says DNL forms, it is used for which one? Optically active compounds. Okay, active compounds. So this optically active compounds, they're going to rotate. They will rotate PPL into which one? Either right D form or left L form. Yes. This have, what is the specialty of this? The D and L isomers, remember, they have similar physical properties, right? Boiling points, density, relative densities, melting points, like that. Similar physical properties would be there for them. Got it? Right. Right. So we are coming to the end now. Like, share, and subscribe to the channel, students. WOC, your world of chemistry for grade 10, 11, 12, always strives for only one thing. Okay? For 10, 11, 12, JE and NEET, always it strives only one thing. Does it expect any money from you? No. It is free education, free and quality education, right? I am there with you all for till you complete your board exams next year also. So the next chapter which is going to come up is alcohols, phenols, and ethers. So stay connected, careful, all the best. Watch for the next video which is coming up tomorrow. Bye bye, students. Thank you.